Okay, so this is logarithmic functions differentiation. This is after the trigonometric functions differentiation we had last time. Okay, so if we have log of u to the base b, where u is a function of x, so we get 1 over u times log of e to the base b, then multiply it with the derivative of u with respect to x. Take note that e here is not a variable. Okay, it's a constant. No, it's the Euler's number, wherein the approximate value is 2.71. Then, if we have natural log, meaning the base is e, okay, so ln can be written as log to the base e. You can recall from your high school mathematics class. So it's derivative of ln u, okay, where u again is a function of x, is 1 over u, and then multiply it with the derivative of u with respect to x. And if we have u raised to power v, where v is also a function of x, so its derivative is you simply copy the given function and then multiply it with the derivative of v times ln u. Okay, so just follow the format. We are going to use the other differentiation formulas, of course. Okay, if we get na the derivative of u with respect to x. So for example, if the base is 5 and u is for x plus 3, so it follows this format no, for D18, where b is 5 and u is for x plus 3. So it says here 1 over u, then log of e to the base b, then multiply it with the derivative of u with respect to x. So simply copy no, the formula and replace them, the letters, the variables with the corresponding values. So b is 5 and u is 4x plus 3. Okay, so if you will be solving for the derivative of this function, dy over dx or dy dx, or we can also write it as y prime. Okay, so it's 1 over u according to that formula. So 1 over u is 4x plus 3, and then log of e to the base b. So b is 5. And then don't forget to multiply it with the derivative of the u. So the derivative of 4x plus 3. So derivative of 4x plus 3 is 4. Let me copy these first. So multiply, okay, with 4. Or you put the 4 before the log notation. So that's this fraction times 4 is basically 4 no, over 4x plus 3 times log of e to the base 5. Okay, so this is the derivative of the given function. Okay, so since we are going to be repeating no, the process of putting no, the derivative of u after writing the 1 over u log of e to the base b. So you can also do that first, get the derivative of u first, and then multiply it with the, this first part. Okay? Para pwede mamata-mata ba, no? So for example, so you don't have to write everything. Okay? So for another example, if we have, let's say the base is 7 and we have, let's say 2x cubed minus 7x plus 4. Okay, so since you will be always multiplying, no, the 1 over u log of e to the base b with the derivative of u, and then you need to transfer that value no before the log notation. So na ko na lang ini mo og solve no. So you can put the derivative of u with respect to x here, and then later na lang si 1 over u times log of e to the base b. Okay, so b is 7 and u is 2x cubed minus 7x plus 4. So derivative of 2x cubed minus 7x plus 4 is 6x squared minus 7, right? And and then multiply it 1 with 1 over u. So 1 over 2x cubed minus 7x plus 4, and then multiply it with the log of e to the base b. It's always log of e to the base b, so b is 7. And since it's always 1 over u, so you can just put the du dx here on top. Okay, so it makes it more um more compact, no? And reduced. Reduced meaning there are a few na lang factors. So we are multiplying the derivative of u with respect to x and the 1 over u. Okay, so it's written, the formula is written this way because this is accordance with the chain rule, no? Na we need to continue the differentiation. So if u is not equal to x, so we need to get, no, the derivative of that function. So another example na shorter pag yun, no, diretso na you write na lang directly the derivative of whatever is written to the right of this log notation. So say log to the base 4 of um 2x raised to 5 plus 7x squared, okay, plus 8. So y prime would be the derivative of the u, so meaning 10x raised to the power of 4 plus 14x, okay, and then over u, so 2x raised to the power of 5 plus 7x squared plus 8, and then log of e to the base 4. Okay, so this is the y prime. So let me write this again. Okay, so that's how you use the 18. Okay, so now if if the base is e for natural logarithm, so example number 4. So let's apply the power rule here. So natural log of 2x plus 1, and then you are going to raise the 2x plus 1 to a power of 4. Okay, so basically, okay, this is your u, so that we can use the D19. Okay, so let u be equal to 2x plus 1. So its form is now ln of u raised to the power of 4, right? So, or rather, our u is the entire 2x plus 1 raised to the power of 4, so that we won't be using other variables, no? So let's have the basta confused na sa gula na sa natuglain variable. So let's stick to the formula for D19. Okay, and then we'll just incorporate the rule. Okay, so we can have this as RU, the entire function, no, including the power. Okay, so that when we solve for the derivative, okay, so following the D19 format, so it's going to be 1 over u. Okay, so 1 over 2x plus 1, okay, raised to the power of 4, and then multiply it with the derivative of the u. So derivative of 2x plus 1 raised to the power of 4. So now we're going to use, okay, the power rule here, no, because this is raised to the power of 4. So just copy this. And then using the power rule, so n is 4. So we copy the n, right? Okay, so it's in the form u to the power of n. So n u to the power of n minus 1 times derivative of u with respect to x, right? So our u here is 2x plus 1. Okay, so meaning it's 4 times 2x plus 1 raised to the power of 4 minus 1 or 3. Then we need to multiply it with the derivative pa, no, of 2x plus 1, which is 2. So if we combine everything, okay, so we have raised to the power of 3 and raised to the power of 4. So we can remove 3 2x plus 1s. Yes, there's only one 2x plus 1 that will be it will remain, no, in the denominator. So 4 times 2 is 8. So it's 8 over usa na lang ka 2x plus 1. Because here we have 3, 2x plus 1 is being multiplied, no, and here we have 4. So common factor is 3 kabuok 2x plus 1. Okay, so the final answer would be 8 over 2x plus 1. Or you can just remove the parenthesis. Okay, so this is the y prime. Or again, similar to D19, you can first get the derivative of u with respect to x, and then before you write the 1 over u. Okay. So, let's go to the D20. So, for example, if we have our u being equal to, let's say, x raised to the power of x. Okay, so D20 is applicable here because the base is a function of x and the exponent or the power is also a function of x. Okay, so if the base, for example, is a constant, so it's an exponential function, no? If the power is contains a variable or is a function of x. So you have a separate list of formulas for that. Okay. If the base is a function of x and the power is a constant, though, of course, we use na lang the power formula. No? So, applicable ni siya if both base and power, okay, are functions of x. So, let u be equal to x and, sorry, v is also equal to x. So, according to D20, okay, the derivative is you just copy the given u raised to the power v and then multiply it with v ln u. Okay, so y prime. So do not change it to y prime yet if you are not differentiating it yet. Okay, so now we are going to use na the formula. So we use na y prime. So x raised to the power of x and then multiply it now with the derivative of v, so which is x, times ln of u, so x ln of x. All right, so we have two different functions. No, x is algebraic and ln of x is a logarithmic function. And they are being multiplied, meaning we need to use the product rule here. Okay, I hope you haven't forgotten, no, the product rule. So we are mixing different formulas na. So x raised to the power of x, and then using the product rule, diba, we copy the first function and then multiply it with the derivative of the second function. So meaning multiply it with the derivative of ln x. And then plus copy the second function and then multiply it with the derivative of the first function, meaning the derivative of x. So let me replace this with a bracket. Okay, the middle or the inner grouping symbol is parenthesis. The outer symbol is bracket para Really confusing. So x raised to the power of x, okay, and then x times, so derivative, okay, derivative of ln x, okay. So we use the D19, okay, because it's ln of x. So meaning 1 over u, no, times the derivative of u with respect to x. Okay, so basically 1 over x, and then derivative of x is just equal to 1. So 1 over x times 1, or just 1 over x. Okay, so again, this is by using D19. Okay, then plus ln of x multiplied by derivative of x with respect to x is just equal to 1. So we can use a center dot instead of parenthesis. No, you can also use a parenthesis to indicate na that you're multiplying the two functions. Or again, you can just use a center dot. So don't forget the PEMDAS. So meaning you need to multiply these first and these before you add. Okay, so x raised to the power of x times x times 1 over x is just equal to 1. Okay, and ln of x times 1, of course, is ln of x. So this would be the final answer. No, no need to distribute na the x raised to the power of x. The final answer can contain, okay, a common factor. So if you're factoring out this, so that's fine. Don't need to distribute, okay, the x raised to the power of x. So another example, let's say we put a trigonometric function. Okay. So for example, if the base is a trigonometric function of x, no, it's a function of x. Also the power is a function of x. So we use D20. Okay. So u is the base. So sine of x, and v is x. So again, follow the format. D20. Okay, na you copy the given function and then multiply it with the derivative of the power times times ln of the base. Okay, so let's just always memorize nga u and v, and then if you interchange, no, basin ang u is the power na and v is the base. Okay, so memorize it na kana, no? Derivative of the power times ln of the base, so ln of sine of x. Okay, so we now have two functions, okay, x and ln of sine of x. Okay, so we are combining na all types of functions here. So just copy the first function and proceed to, again, product rule. No? So u is x for the product rule, and p is ln of sine of x. So if you don't want to put the differentiation of v or u, okay, below, so you can just put it here. Okay, para dili daghan isulat ba dito sa ubos, no? So you are going to multiply later, okay, derivative of u with respect to x and derivative of v with respect to x. So might as well ato na lang ibutang daan diri, no? Na derivative of u with respect to x is 1. Okay, derivative of x is 1, and for derivative of v, okay, it's ln of u, where u is sine of x. So using D19, no, another round of D19. So using D19 is, yeah. Okay, this one is, of course, using the properties, no, of derivatives. Dx over dx is just equal to 1. Okay, So using D19, so ln of u is 1 over u. So it's going to be 1 over sine of x times derivative of the number beside the sign, no, notation. So meaning times 1. Okay? So you can do that, no? Na before we put everything dire sa next line of the solution. Balik, isolve na lang ni mo daan ba, no? Ready for the product rule. You don't want to write no, a lot of things there sa ubos, like for this one. Okay, so giusa lang siya. But you can always no solve for the derivatives of the functions. Okay, para ready for product rule. So using product rule, okay, so derivative of x times ln of sine of x would be, you copy the first function, meaning u. Okay, so it's x multiplied by the derivative of the second function, meaning derivative of ln of sine of x, which is 1 over sine x times 1, or that's basically sine x. And then for the second term of the result, using the product rule, so you copy the second function, no? Uh, ln of sine of x, and then you multiply it with the derivative of the first function. So derivative of x is 1. Okay, so you just get rid of the 1 multiplied to ln sine of x. So it's x sine x plus ln sine x. So this is the final answer. Okay, let's see. Ay. So u is sine of x, no, it's a trigo function, no? It's going to be not equal to 1, sorry. Okay, so you need pa to get the derivative of the u, okay? Because u is a trigo function, no? So what you're going to multiply here must be the derivative of the trigo function and not just of x. Okay, sorry for that. So let me erase this part. Okay, so isa ko naman tanan. So again, the derivative of ln of sine of x. Okay, so that would be 1 over u, no, using D19, 1 over u times the derivative. So let me write it down para mas makita, no? So multiply it with the derivative of u, and u is sine of x man di ay. Okay, so therefore, dv over dx is 1 over sine x. And then from the trigonometric functions differentiation, derivative of sine is cosine x. So we have cosine x over sine x, or that is equal to cotangent of x, no, using the ratio identity. Okay, cosine over sine is cotangent. So let me move this again. Okay, so y prime would be equal to sine x, quantity raised to the power of x. Then, ano to, the product rule. So, copy the first function and then multiply it with the derivative of ln sine of x, which is cotangent x. And then plus, copy the second function and then multiply it with the derivative of the first function, meaning multiply it by 1. So, sine of x, okay, quantity raised to the power of x times x cotangent x plus ln of sine of x. So this is the final, okay, answer. So we are combining na algebraic functions and transcendental functions. All right, so that's all about logarithmic functions differentiation. So next would be the exponential functions differentiation.